Okay. British Grenadiers song. Sung done long time ago. You're exposed to a little bit of history, but I want to point out to you there were those blokes who built the British Empire. Mind you. Okay? Now, let's go on. Chapter 9, Part B. We've covered a lot. 9A is a big chunk. It's a big pie, right? Gave you like a couple of quizzes, gave you a test. Here we are at 9B. We're going downhill. Now, the reality is, one of those, the first objective there, we've pretty much covered it. Okay? Where you're going to solve stoichiometric conversions between moles, masses, number of particles for any substances of a chemical reaction when given a balanced equation in one of the quantities. We're okay with that. You will be able to identify limiting and excess reactants in a chemical reaction when given one of the quantities. We already talked a little bit about excess reactants. Now we're going to know what's limiting. Student will be able to calculate the excess amount of a reactant in a chemical reaction. That's a pretty easy thing to do, okay? You will be able to calculate the theoretical yield in a chemical reaction when given the quantity of a reactant, okay? And then you'll be able to calculate the percent yield when given the actual yield from a chemical reaction. Whew, wow, it's getting a little hot in here. Okay, what do we have? Let's go with it. Apparently, let me see. Okay, I'm still learning the screencast thing. Okay, so in looking at stoichiometry, there's a couple of things you got to look at. One, Deuteronomy 25:15 says, "You must have accurate and honest weights and measures so that you may live long in the land the Lord your God is giving you." You know, that's a pro tip. If you look at God's word as truth, if you're looking as the source, the very words of God breathed in to man, human writers, okay, this is an extra pro tip right there. Being honest with your weights and measures. Because you try to cheat the wrong person, yeah, they could try to hurt you. Pro tip. Okay, so what is stoichiometry? You may have heard me mention it. Okay, stoichiometry is the measuring and calculating the mass and mole relationships between reactants and products in chemical reactions. Some people might be thinking, wait, didn't we do that like 2 weeks ago before that whole coronavirus thing hit? Yeah, we did. You had a pretty good taste of it. Okay. So let's talk limiting reactant. You got excess reactant. Okay, we did the moles to moles thing. We said, hey, there's this excess reactant. Okay. Now, a limiting reactant is what gets used up first before the other reactants in a reaction. That's a pretty important idea because if you want to make a certain amount of something and you have an excess reactant, then what's going to stop you from making that certain amount of something is the one reactant you don't have the never-ending supply of. Okay, it could be your most expensive ingredient. Okay, that's just the way it is. So there's the limiting and the excess reactant. I'll show you guys how we can figure that out in a chemistry problem. It's not that hard, and it's really nothing new, no new tools to use, but you're going to be using a couple of tools. Okay? Now, that being said, we got to talk about theoretical yield and actual yield and percent yield as we wind down the concepts of this chapter because we're going to do the math in a separate video. Okay? Theoretical yield is the maximum amount of product that could be created from a given amount of reactant. So in other words, in the perfect world, where apparently Addison Rowe is going to get some award for being a TikTok star, okay? That would be like the perfect world for some people, okay? Theoretically, I should be able to get, 500 grams of gold by the time I'm done with this chemical reaction, okay? Now, that being said, there's theory and there's the real world. Some of you guys are thinking the real world. Oh man, he's talking about that again. Yeah, I love that to be a trademark. Okay, so we got to look at the actual yield. That's the measured amount of product at the end of a reaction is called the actual yield. The percent yield is the percentage of the theoretical yield that was actually produced. Okay. Actual yield, theoretical yield. Let's take a look at this. If I theoretically can make 500 grams of gold from my chemical reaction, and I actually got 400 grams of gold from my chemical reaction, I'm missing 100 grams. Bummer, okay? Because that's not a cheap process. So my theoretical yield is 500 grams. My real world, I physically took the gold and measured it out, and it was 400 grams. Okay. All right. So that being said, then that would mean that if I look at, let me see if I can, I got to move around here. There we go. Let's go to shapes here. Shapes. Nope, they're not, come on, give me something. Okay, here we go. Oh, that's a straight line. Come on, give me something a little bit better. Hang on, guys. I am trying to find something that will work. Okay. So, why am I doing it that way? It's easier if I just use numbers. Okay. Well, guys, here's something to think about. Why in the world do we have actual yield and theoretical yield? Why bother with a theoretical yield in the first place? Why is it that the actual yield would be less than the theoretical yield? There's a number of reasons why that can happen. So let me give you a real life story, and maybe that'll make a little bit more sense to you. World War II has started. The U.S. is now at war with Japan. The U.S. has Army, Navy, and Marine guys over in the Philippine Islands. The Japanese invade the Philippine Islands. The Japanese have tanks. They're coming down the road. Now, the Americans also have tanks, and they're going up the road. Now, the American tanks know if I fire my bullet from my gun, from my tank, I should be able to hit and take out the Japanese tank at 500 yards, not a problem. Well, battle happens, and the Americans tanks, they did what they were supposed to do. They fired, and this is what happened. Here's the Japanese tank, here's the American bullet. What's wrong with this picture? It's not punching through. The bullets are not strong enough to penetrate the armor of the Japanese. Well, wait, what happened? Our theoretical yield says we should be able to do this, but the actual yield says, no, that's not happening. What happened? Something was wrong with the gunpowder, okay, in the bullet. And what they found was that in the tropical climate, there is a lot more humidity, the water that's in the air. And that messed up a bunch of the powder in those bullets that were there in the tropics. So what happened was they would fire and not all the gunpowder would work. So you had a theoretical yield, but the actual yield was less than the theoretical yield, and that cost Americans, some of them, their lives. We lost some tanks because of it. So, first battle is over. Now we go back to another battle. This time, what the Americans did, they waited for the Japanese tanks to come closer because now they know their bullets aren't that good. They wait for the Japanese tanks to come closer. They fire. Boom. That did the trick. Now they were able to take on the Japanese tanks. But that was not going to change what history was dictating. The Japanese would take over the Philippine Islands. The Americans would either become prisoners or they joined with the jungle resistance fighters, okay, or they died. Very few escaped. Very few of them escaped that. So, there's chemistry in the real world for you. The gunpowder not completely going off the way it should. Bummer. Let's get back to business here. Now, let's think about this, okay, for a moment. Okay, hang on. It's... Okay. Let me cut that line. Now I'm going to go ahead and I'm going to do something a little bit different. I'm going to go and I'm going to use the numbers. Okay. So here's the deal with this. I said I have 500 grams. That's my theoretical yield. Okay. I add 400 grams actual yield. Remember, this was my gold that I got. I'm making gold. Well, actually, I'm getting the gold out of the rock, and this is what I should be producing, 500 grams. That's my theoretical yield, but the reality is I only got 400 grams of gold out of this. So I'm going to say 500 grams gold, theoretical yield. But in reality, I got 400 grams of gold. That's the actual yield. That's what I physically got. Let me do this a little bit. Oh, come on, guys. There we go. So this is what I have. So now I got to look at the percent yield. Now that's a pretty important idea. What is my percent yield? Because my boss is going to want to know, hey, Mark, what happened? You know, what? Give me the percent. What was the percent yield you got? Okay, I trusted you with all this stuff. I trusted you with the gear. You had the right people, the whole bit. What's my percent? What's the percent yield that I got? Okay, so here's the thing. The percent yield is equal to the theoretical, okay, and that's going to be divided by the actual. And I'm going to take all that, so I'm going to put this in parentheses so you guys can see that, and I'm going to multiply that times 100. And that is going to give me my percent yield. So what does that mean? So I'm giving you guys the formula. You probably would want to write that down. So I get 400 grams divided by 500 grams, right? And let me put that in parentheses so you guys can see that. Times 100. And, well, this is not going to be good. This is not going to be good because guess what, ladies and gentlemen? That is equal to 80% yield. Okay. I am so fired. Like my career is over. I had all that gear, all the stuff, all the people, and I got 80%. Okay. Hand on hip, flip hair, roll eyes. Oh! Oh. Now, some of you guys might be thinking, wow, 80%? That's not too bad, man. It's like getting an 80% on a test, and I usually get like a C plus or something. I'm thinking that's pretty good. Well, you know what? Not in the business world. In the business world, a percent yield like that, it means you screwed up. You messed up. You're not good at your job, and you ain't keeping your job. Okay? You're not. So I'd be fired. I'd be so fired, I'd have to go into another line of work, like probably being a rapper. Probably. Okay? So, that being said, that's the theoretical yield. You had your theoretical. Oh gosh, I screwed up, didn't I? Oh my gosh, I screwed up. Guys, okay, this is what I did wrong here. I'm so sorry. Please forgive me. I'm going to put that in there. And I'm going to put the slash mark there. That's the correct formula. I am so sorry. It's Saturday for me, and I am kind of like mentally burnt out. I've been doing this all day. So I am speaking to the future, and you are hearing from the past. All right, but no, it's fixed. It's done. Remember, it's actual divided by theoretical times 100. And we're going to spend some time. I'm going to do another video where we are going to be looking at this. I'm going to show you how to calculate all this stuff, okay? All right, let's wrap up. So for us, we looked at the idea. We looked at the idea of stoichiometry. Basically, it's what we've been doing this chapter. We've talked about the idea of limiting reactant. What gets used up first before all the other reactants in a reaction? We also talked about excess reactants. You were previously exposed to that. That means you've got plenty. You're never going to run out. Okay? It's kind of like my cringeworthy moments. All right? We talked about theoretical yield, the idea of the maximum amount of product that you can get from a given amount of reactant. We also looked at the idea of an actual yield, okay? And the percent yield is the percentage of the theoretical yield that was actually produced. So guys, that's it for the concepts of Chapter 9. We're going to work a little bit more with this during our time together, so that's going to take a couple more videos. All right? Hey, you take care, God bless you, and have an awesome day.